In this video, let's take a closer look at the essential components of a big data management system. This will provide you with an overall picture of the big data reference stack. First comes the data sources. These sources comprise myriad databases belonging to various enterprise applications, containing data in structured, semi-structured, or unstructured forms. The data lake is where the accumulation of raw data happens. This is a central repository where all the data pulled from the data sources reside. The data lake is very flexible. It is optimized for data ingestion at a massive scale and supports preprocessing such that data scientists and analysts can easily restructure raw data in various structural formats. Next comes the data warehouse. A data warehouse is a large storage system that aggregates data collected from multiple disparate sources. It is partitioned into many data sets, each representing a specific data experiment to unearth insights from the raw data. Data warehouses are optimized for storing large amounts of analytical data, without relational linking and table-based structuring. The analytics engine is the most important component of a big data management system. It is where all the number crunching happens, which transforms the data into something that is insightful and easily consumable for business analysts. If we consider the stacking order, the data lake sits at the bottom, followed by the data warehouse and the analytics engine at the top. The data lake is like the central repository of all the raw and preprocessed data. The data stored in a data warehouse is a subset of what is available in a data lake, but in a processed form that is suitable for performing analytics. That is the result of the analytics engine operating upon the data warehouse to run multiple analytical processing workloads. In reality, there are multiple instances of a data lake in operation within an enterprise big data management system. This is done to partition the raw data from preprocessed data. And the same goes for data warehouses, with multiple instances containing semi-processed data in various stages of the complete processing cycle. This also extends into separate staging areas for holding training, testing, and model data for complex machine learning-based analysis. The analytics engine is also split into multiple instances. Each analytics engine manages a dedicated set of data pipelines. There is one instance that works on the data pipeline that transfers the raw data from the various sources to the data lake. In most cases, this is known as the ETL pipeline, which performs extract, transform, and load operations to perform some degree of preprocessing on the raw data before storing it in the data lake. Additionally, it also bridges the data path between the data lake and the data warehouse. This is required for continually updating the data warehouse with new data that is ingested from the data sources. There is a separate analytics engine instance that dedicatedly operates upon the data warehouse. It performs the most intense data analytics and machine learning operations to derive insights from the preprocessed data. This is where most of the core analytics computation happens. Finally, there is one more analytics engine instance. It bridges the enterprise application and the data warehouse, for querying the datasets containing the final analytics output. In this way, all the components of a big data management system are stitched together via a set of data pipelines.